We're now going to take a look at a second method for finding the slope and then use that method to write the equation of a line given to us in a graph. So we can also find the slope using the formula m is equal to rise over run. So I'm first going to show you how to do that on a graph. So what you need to do is identify 2 points on the graph. Now on this graph I've already dotted in a point here and a point here. So what I'm going to do is start at one of these points and I'm going to sort of draw a triangle that's going to look like this. So I'm going to go up until I get even with the point and then I'm going to go over. The up and down movement on the side is going to be what we're going to refer to as the rise. So this part will be the rise. And the movement over, either to the left or to the right, we'll refer to this as the run. So if we move from this point at the bottom at 4 and we move up, the rise is going to be positive. If we had moved down, the rise will be negative. All right, so I'm going to count up and I'm going to count the boxes on the graph. So this is 1 and this is 2 and this is 3. So there are 3 boxes that I'm rising up on the graph. So my rise is going to be 3 and my run going from this corner point to the black point is just 1 box. So the run is going to be 1, and since we're moving towards the right, it is also going to be positive. All right, so that's going to tell me that my slope is equal to 3. Now another thing you can do, we've already talked about what would constitute a positive versus a negative slope. So you really should know before you even got started that this would have a positive slope because it's moving in a positive direction, like we talked about in the last section. All right, so once we have that, we are almost ready to write our equation. So I'm going to go ahead and kind of set my equation up. I'm going to say f of x. And I'm going to plug the slope in for the m value in the function. All right, so the slope is going to go right here. So I'm going to have 3x. And then I need to add my b. Now remember, the b is the y-intercept. So we want the point where the graph crosses the y-axis. So if I'm looking at that graph, we want to note where the graph is crossing the y-axis. So it's crossing right here at 4. And so I'm going to enter a 4 for my y-intercept. And this will be the equation of the graph shown in the picture. All right, let's take a look at one other example, very similar. So the first thing we want to do is find the slope of this line. And again, we're going to do it by using rise over run. So we're going to identify 2 points on the line. So we actually have several points identified here already. I'm going to go from the middle point to the point on the right. It doesn't really matter. You could have gone from the middle point to the point on the left. All right, so coming from here, I'm going to drop down. Remember, you're drawing a triangle. And when you get level with the point, then you're going to go across. All right, so the rise is this part. So that part's going to come first. We're going to count the boxes between the point and where we made the corner. So that's going to be 1, 2, 3, 4. So my rise is going to be 4. That goes on the top. And the run, we're going to count boxes going across. So 1, 2, 3, 4, 5 to get to the point. Now, you know from what we talked about in the last section that this slope should be negative, correct? Because the line is moving in a down direction. So I'm going to go ahead and put the negative on the slope, and then we are ready to plug into our formula. All right, so again, our formula starts out f of x I'm going to plug my slope in for the elm, so it's going right there. We're going to put the x next to it. And then we're going to add the b value. All right, so what is the b value in this case? Where does the graph cross the y-axis? So we're looking for that point where the graph intersects the y-axis. We see that happening right here. And that point is it's halfway between the 2 and the 4, so that's going to be 3. All right, so again, now we have an equation here for the graph of the line shown in the picture.